So today we're going to talk about something called Pythagorean Identities. It's one of the most important things you guys will take on as you go through pre-calc and calculus. It comes up quite a bit in upper level math. For you guys, we're just going to do like the basic recognition of what a Pythagorean identity is, and it has a lot to do with this idea of a Pythagorean theorem. All right. Good, Frida. A squared plus b squared equals c squared. Great. We use that like all the time yesterday, right, in our homework. Now, with this a squared plus b squared equals c squared, you guys will see kind of how it relates to this Pythagorean identity idea. And real quick, let's just do a quick review of your reciprocal functions, because that's going to come into play today again, too. Cosecant right here, and then cosecant. Okay. Anybody know what cosecant is? Good. It goes with sine. Nice. So it's 1 over sine. Great. What about cosine? 1 over tan, or cosine over sine. Remember these, like cosine, cotan. All right. What about the secant? 1 over cos. Good. And tangent? Nice job. Great work. Super. Great. We're going to do all that stuff again. Keep coming into play. All right. So unfortunately, yeah, this Pythagorean identity idea, we're going to have to memorize it for your Regents exam, but it's not as bad as it looks. Right? We've talked about in our right triangles quite a bit that your first order pair is your cosine, the second one's your sine, right? Cosine is like the x, sine is like the y. And you guys had this on like your last test. The cosine was the x part, like the horizontal. The y is the up and down. The sine is the y part. Now, if you guys knew, what's your radius on a unit circle? 1. Okay. Right. It's always going to be 1. So if you look at this triangle and look at your Pythagorean theorem, well, the a and the b, what are those like in here? Anybody have an idea? They're the legs. Good. What do they represent? Cosine and the sine, the x and the y. Good job. So really, this is like saying the cosine squared plus the sine squared is going to equal 1, which is your hypotenuse squared. So this is where your identity comes from. It's coming from you're really using a Pythagorean theorem on unit circles. So the most important one we're going to see is this idea that sine squared theta plus cosine squared theta always equals 1, no matter what. It's called an identity because you can plug in any value for theta you want. Okay, we can make theta be 30 degrees, 45 degrees. But if we figure this out and we actually do it, it's always going to be 1 no matter what. Now, if you remember this first, if you remember this first identity, okay, we can use this to find the other two. And we do this all the time in calculus because I don't want you guys to want to memorize more than you need to. Probably not. You know, you already have enough to do. But if we know the first one, we can get the other two by a process called deriving. Right? And this is really what it's called, it's deriving. Right? So we start with the identity we know, and if you divide everything on there by cosine squared, right? Everything divided by cosine squared. We're going to look to see what the fractions are that can be reduced to. So if we divide each part of this by cosine squared, look to see, what was sine over cosine? What was that? Tangent. Good job. And since these are both squared, yeah, nice, good, tan squared. Okay. Now if we have cosine squared, good, divided by itself, it's just 1, good. And what was 1 over cosine? Yeah. You got it. Good, and it's going to be squared, nice, Maddie. Yep, because we're dealing with squared functions on the bottom, so this is going to be squared as well. Okay, now if we look up to our second identity, tan squared plus 1 equals secant squared. Isn't that what you guys just got? Yeah. So we don't have to memorize these next two. By using this idea of deriving, we can get the other two. Right? Your Regents exam really focuses on just the first identity. I mean, it's not to say they can't be real mean and throw one of the other ones in there, but I've seen them ask this idea of deriving right, on a Regents before. They actually said, like, derive them and find the other two.
Was there part two?
Yeah, it was a part two. Yeah, it was exactly a part two.
So you really don't have to, like, do any, like, math work, you just have to remember it.
Yeah, yep. Now, we have two other identities, right? You got the second one. Now, to get the third one, all you're going to do is divide everything by the times sine squared. So go ahead on your papers. See if you guys can divide it by sine squared and reduce it, just like you did the first one. It should hopefully come out to be the third identity.
Can I just read the answer?
That's what the answer is. Yeah. Nice try. You're just being here. Everybody always forgets the square. Just make sure it's careful.
Does it matter if it's a theta in front of the sine squared, right?
Yes, it does. Frieda just asked a great question. Okay. And this is a little bit weird because usually when you guys see something all squared, if I gave you guys x squared, it's just at the end, right? You're going to put your square at the end. When we're dealing with trig functions, it's kind of like the first time these squares have come up. You're going to be putting the squared sign always between the trig function and whatever the angle measurement is. So we use theta a lot for empty angle measurement. If it was like an x, it'd be like tan squared x. The squared always goes between.
When you point out between
No. Look at my soft spot. I know, in the middle, you know. I'm gonna pick on Maddie. You did this good stuff. What's your sine squared over sine squared? 1. So which means this one?
Tan squared.
Cosine squared. Did you have cosine squared? Equals. Perfect. Good job. Right. Now, bless you. The way you guys are going to see these come up, it could be a variation. They might just ask you really straightforward. We're going to have to do a little bit of work with your trig functions. Now, anytime you guys see a 1 being added or subtracted to a trig function that's squared, it might be from one of your identities. Yeah, Andrea?
Why can you divide it without it equaling? Like, I don't know how you solve for an equation and divide x if you find x. Why can you just divide it?
Like in here?
Yeah.
It's because you're dividing on everything on both sides. You could think about it like, an example of, all right, let's say I have 2x squared plus 4x minus 10 equals, I don't know, give me 0, that's fine. So if you were going to solve something like this, okay, what would you look for first? GCF, good. So this one has a GCF of 2, right? So if you took out a 2, you'd have x squared plus 2x minus 10 equals 0. And you keep, oh, sorry, minus 5, thank you. So then, if you wanted to solve this, you could keep factoring in here. But what's really going on, you know how when we said this 2 equals to 0, it's like nothing? The reason why is because you could really be dividing everything by 2, and this is still going to be 0. So it's as long as it's taken out of the entire equation. Right. You're kind of like, you're essentially kind of like factoring out like a GCF. Okay. Does that make sense when you look at it like here with the numbers? Yeah. As long as you're being consistent, what you guys are doing on one side, you're doing to like everything. That's a good question. All right. So with these identities, we want to be careful. If we see 1 being added or subtracted to trig function squared, it's probably stemming from one of them. Now, your main identity is this idea that sine squared theta plus cosine squared theta equals 1. Now, you could see variation. Going to kind of what Andrea was saying, if you guys are looking at moving things around, how would you get sine squared by itself? What would you have to move? Good, minus that cosine squared. Good job. So you can bring cosine squared over. So if I saw 1 minus cosine squared, what does that equal? Well, what's left? Sine squared. Nice thinking. Yeah, it's just equals what's on the other side. So even though they give you guys your identity that sine squared theta plus cosine squared theta always equals 1, right? You could solve for parts of it like an equation. Same thing with your tan squared theta plus 1 equals secant squared, right? We can move things across your equal sign. If I wanted to get secant squared alone, what would you guys want to do with this one? Add 1, right, Carly? Right. So I would know then that tan squared theta plus 1 equals secant squared theta. So you guys can think about this just like a normal equation. You're just moving things across your equal sign. So the way these show up looks something like that. Or what you guys are going to see. Now, anytime you guys see cosine squared, here we have a phi theta plus a sine squared phi theta. Right? Anytime, if you trig function squared, maybe one's being added or subtracted, we want to look to our identities and see maybe it's made up of one of them. What do you guys think? Which identity do you think this one goes with? Any idea? Yeah, Joey? First one, good job. The idea that sine squared theta plus cosine squared theta equals 1. Now, as long as your two values here are the same, right, it will always equal 1, no matter what. Right? You could have 10 theta, 100 theta, 1,000,000 theta, but as long as these are equal, it will always equal 1. Does it matter that cosine squared came first? Addition, yeah, commutative, good job. So what do you guys think this whole thing is equal? 1. Great. Yeah, that's it. 1's just the answer. I see a lot of times on your Regents exam, questions that are that easy. They'll say, what is sine squared theta plus cosine squared theta always equal? 1. All right. So that comes up quite a bit. Right. So a secant squared theta minus 1. All right, let's look to see which trig identity you guys think that came from. Right, you need to go back to your identity page. Right, we want to find one that has. Oh, sure. You want to look to see which one's got a secant squared and a 1 in it.
The CSC.
Right, so you want a secant squared and a 1. Yeah, that's like the second one. I think this one right here does. Okay. All right, so tan squared theta plus 1 equals secant squared. Right, so here's our second identity. Tan squared theta plus 1 equals secant squared. All right. Well, they want to know what secant squared theta minus 1 would equal. So let's use our identity and figure that out. How would you guys get secant squared theta? How could we get a minus 1 over to this side? Yeah, minus good, Carly. Minus the 1 from the side. All right. Well, what would secant squared theta minus 1 equal then? Tan squared theta. Perfect. Tan squared theta. Great. I don't see a lot of stuff with the second and third identity, but
Do you have to remember that?
the second and third one? Well, what I would do, honestly, if you remember the first one, you know how in the beginning we derived them?
Well, then how would you derive that?
What, this one right here? You would, so you go to your...
So you always, if you have the first one, you always divide by cosine and then by sine?
Yep, always. So Frida, you would get this, like your original second identity, by dividing everything just by cosine.
Well, you have to memorize it or answer. You
No,
just
you have to
memorize
memorize
like you memorize like the first one, and then you can get the other two by dividing cosine.
Exactly.
So like pretty much you could just like write them all out and then like see which one you want.
Yeah. Maddie, that's perfect. I would not waste your time memorizing these two.
Yeah, but
because Frida, you did a great job with this, right? Dividing everything?
Yeah.
And reducing? That's okay.
But I don't know, just going backwards. If we also the secant squared theta minus 1, can I have to go backwards?
You do have to kind of go backwards. You have to pick which one it came from, and then kind of do.
Well, because then all you have to do is remember the first one and then get the second two and then distinguish which one goes with it.
Right. You'd have to do all three of them, and then pick out, like, right, so you have a secant squared minus 1. So if you did all your deriving like Carly's saying, right, here's your three identities. You want to choose which one's got a secant squared and a 1 in it. The second one, so you have to use this one.
Okay.
All right, that's kind of how you pick. Again, knock on wood, your Regents will probably not give you the second or third. I know.
So like if this is on like a quicker test,
Yeah.
it'd be like basically like the top one where you just find the thing, or is it gonna be like the actual?
You guys, like the next part of this is actually like applying it, so that's how you guys would see it. Give me one second. All right, so here's your next one. You have 1 minus sine squared. Take a look through your identities and pick out which one's got a 1 and a sine squared in it. Write that one down. You can go back to your cover if you need to. And find out which one's got a 1 and a sine squared. And if you want to pass that down. Let's see. Oh. Now, we're going to get 1 minus y squared. So we're over here. Yeah, I did. Good job. Okay, which one did you choose? Aaron, which one is it?
Sine squared theta equals sine squared.
Good. Equals 1, perfect. Now, if you guys want 1 minus sine squared, you got our 1 over here, what would you have to move?
Just the square.
Sine squared. Good job. So we move that across.
So then if 1 minus sine squared theta would be the same thing, right?
Yes, exactly. So 1 minus sine squared, look what's left. It equals cosine squared.
It was, in the beginning it didn't make sense because
I know, this is like one of the, this is a weird topic. Right, now Maddie asked me, like, how is this going to be asked? Because this is a little weird. So flip it over. Okay, these are the questions that are right from Regents exam, kind of how you guys would be asked to apply this, all right? So whenever we're working with trig operations, we want to make sure that everything's written in terms of sine or cosine, okay? Then we're going to follow the normal rule. So in our first little problem, we have 1 plus cosine times 1 minus cosine. 1 minus.
You have to FOIL, right?
FOIL, yes. Go ahead, guys. Why don't you FOIL it out? Some of you might recognize something special with this.
Oh, it's first and last, right? The green one, right?
Oh, it is sweet green. Great. Anybody want to do that? That's perfect. Good. Oh, nice. You already got it. Lauren, what you got? When you FOILed all this out.
1 minus cosine squared x.
Good. All right. So hopefully you got 1 minus cosine squared x. Now Carly noticed something. Did you have to do the whole FOIL here? No, just good. Because these are conjugates, right? They look exactly the same except the middle signs change. Now, if we look at our options, do we have 1 minus cosine squared? No. So this is kind of where, Maddie, you're going to see these questions be asked. Anytime we see a 1 being added or subtracted from a trig function squared, it probably has something to do with one of the identities. Take a second, we need to go back to your cover. Which identity do you guys think has the 1 and the cosine squared in it? First one, thank you, Andrew. Sine squared theta plus, now here I have x's, so I guess I should probably put x's instead. Plus cosine squared x equals 1. Well, I want 1 minus cosine squared. So in your identity, good job, Carly. Nice, minus your cosine x. So what is 1 minus cosine squared x equal? Sine squared x. Nice. So sine squared x is what this thing really equals, which is choice 3. Does that make a little bit more sense, like how you guys are going to see it? You're going to have to probably do some kind of operation and then look for your identity, maybe somewhere in there. Okay. Let's try another one here. So for example 2, see how you have mixed trig functions going on here? Okay, so your first step is we always, to simplify, we always want to write things in terms of sine and cosine if we can. So we have a sine already, we got a cosine, but we want to rewrite tangent in terms of sine or cosine. So how could you guys do that? Good, sine over cosine, nice job. I told you guys it's going to keep coming up over and over and over again. You got it. Good job. Very nice. Because we have a complex fraction that's formed, so you have to copy change left and forward. Take a second. See if you guys maybe can figure out what's going to cancel out. What would we have left if you guys reduced it? Okay. Sorry.
No, it wouldn't repeat the But those would just cancel out. If you would multiply them. That's one.
Anybody think they got it? They can show their work. Perfect. Oh, no, that's right. This is the first chapter.
See, I get confused about whether or not to cross multiplication or talk about it. Well, I think that only works
Very nice for you. Great. Good job. How'd you guys do once you set it up? Good. With the canceling? Now here you have the answer. You don't have to do anything with an identity. Sometimes you do, sometimes you don't. Okay? Now example 3, a little bit tricky. Okay? Do we have everything in terms of sine and cosine? Yeah. So let's put, we're adding fractions here. Who can tell me what we need when we add fractions? Common denominator. Yeah. Actually, it's still a trig function. What a pain. So, yeah, Deanna, go ahead. Good. So you want to just make sure you're like keeping things like organized in your books. Yes. Good job. Keep in mind you guys are adding here. So once you make that comment, oh, very nice. So this test is going to kind of be like moving with your numerator.
Remember this? This is an identity. That's right there. This right there. Oh, this right here. This is an identity. Okay, so then I'm going to that same identity. So I just do 1 over the cosine b.
Do you think what you have left? Great. Good. Okay, so it looks like we're all right, this is good. You guys are all at the same length apart.
Oh, no.
Look. All right. Jameson, what did you multiply by here?
Cosine B.
Cosine B. Okay, this was great. No. Okay, so I thought like everyone did a great job getting a common denominator, right? What you guys had left, we had sine squared B plus cosine times cosine is going to give us cosine squared B over just cos B. Now, a lot of you guys left it like this. Now, it's not an answer. Look very carefully at the numerator. Is anything like jumping out at you? Oh, it's the identity. Good, Nadine. It's the first identity. What does sine squared of anything plus cosine squared of anything equal? 1. So this whole thing just equals 1. So it's really like saying 1
Dumb.
over cosine B, which is 2. Yeah, because it was
I multiplied the bottom.
Oh, no.
So then I could cross out the middle with sine squared.
Not fair. All right, try out the next 2. See what you guys get with those. Okay. The next ones are kind of nice.
I don't know. They're nice?
Yep. Good. Make sure you're leaving sines and cosines, so rewrite this.
It's 1 over. Yeah, 1 over.
Where?
Yeah, I think it's
No matter what. You think we're the same. If you think you know it, I'll check you when it comes out.
I'm confused. Again, I don't think it has to do with it. I have no idea. Oh, wait.
Yeah, perfect.
Square root.
Doesn't equal everything else.
I don't know.
Is that identity?
I give up.
No, I
Joel, did you ask me?
Rewrite it.
Okay. So we'll just bring this back and bring it up. Oh, bring it up. My dad. Yeah, but then if you could have both, like, or say that. It'd be a lot easier. But if you just put it right there, it's not much. Okay.
Yeah, put it over one. Yeah, that's really good.
I don't know where to go. Did you get? Oh, yeah, that's what I did. Yeah, I mean, it's just that, yeah.
No, that's all you can do.
I don't think
that's it.
I don't. Yeah. Wait, what are you doing here?
Letter B two.
What? That pen is just.
We do tangent.
Oh, okay. Just then it would be.
Guys, I saw really good stuff with this. Okay. Now, if you guys left it, cosine x over sine x, a lot of times they won't see this. What does that really equal? Cosine, yeah. All right, they'll write it using one trig function most of the time. Now, same thing with the tangent. I saw a lot of you guys doing a great job with this one, but you want everything in terms of sine and cosine. So what does tangent be? Good, sine over cosine, great. Now, secant is perfect. Now, can we cancel out two bottoms?
No.
No. You can only do one that's on the top, one that's on the bottom. Good. And on the top we have a? Yep.
That part, but then.
Can you do anything here? No, that's it. This is it.
This is why trig confuses you because you don't have your answers right and then you get all scared and you do something.
I know. It's craziness. All right. So here's your homework for tonight. 15 to 22 all. Okay. All right. It's set up just like what we did in class. You're just doing one operation. Make sure you rewrite it in sine and cosine. Okay. Your quiz is tomorrow. Okay. Here's what's on it. Your quiz. No. Just this stuff right here. That's it. Okay. So converting degrees to radians and radians to degrees. So make sure you guys know your conversion. Finding an exact value, like Rita, what you were asking me in the beginning. So you would make your radians to degrees.
It has to be.
Yeah, I'll do it after. And then theta equals that overall.
Yeah, I guess I'm not.
Okay. So if you guys want to stay after and just do a quick little quiz review, absolutely. Right. Listen, on your way out of here, okay, on the back, I'm just going to mark off. Did you understand what we did today, or did you not? Just take a piece of chalk, mark it out, and write it out. Okay? Do you have a middle? Sure, we can put a middle up here.
What if, like, I know what to do, but I just don't know if I get the right answer at the end?
I don't. I'll be in the middle then.
Okay. I'm not confident in myself. Yeah. So, like, once we did on the back of the first paper, you can't minus that.
Oh, yeah. Think about more like when you were back on the
Like what we just did?
Yeah.
Oh.
Yeah, think about more like what you just did, because that's what you're going to do. So just on your way out, or I think this needs if you need more time, you can get it all, we can do more. Alright, so we'll do after school. If anybody wants to review for the quiz. Oh, I forgot to stop recording.